Hello, welcome back, student. Today we are going to see the next topic in the unit 1, that is conversion of FA to RE. What is this FA to RE? FA to RE is nothing but finite automata to regular expression. Finite automata to regular expression. How to convert this we will see. Okay. There is some of the rules in the finite automata to regular expression. Finite automata is nothing but as we are doing the state diagram. Okay, state diagram, take the for understanding purpose. Finite automata is state diagram. Consider state diagram. Regular expression is nothing but like whenever we are checking the string and we have the some of the regular expression as I shown you in the previous classes. So here from state diagram to regular expression, for that there is some of the rules. From that rules we need to conversion from FA to RE, finite automata to regular expression. Okay, the first point is the transition diagram. Transition diagram or state diagram must not have null or epsilon transition. Means when you have a transition diagram, that should not have the null or epsilon transition. Next, it must have only one initial state. Okay, in transition diagram that should be a one initial state, the condition. Next, it vertices are V1 to Vn. Okay, what is this V1 to Vn? Like any vertices, like this is 1, 2, 3, 4. Okay, Vn to Vn means V4, 1, 2, 3, 4, like that. Vi is the regular expression representing the set of string accepted by the system when Vi is the final state. Okay, when V is a regular expression representing the set of string accepted by the system when Vi is the final state. Okay, if you are very difficult to understand this, no problem. When we solve the problem, then you can easily identify, you can easily understand. Epsilon is added to the initial state. Okay, epsilon is added to the initial state, but in the state diagram there should not be a epsilon transition. That means from one state to another state there should not be a epsilon or empty like this, null. This should not be happened. If you have, and in the initial state you can add the epsilon. In the initial state you can add the epsilon. If there are more than one final state, then we have to take the union of that final state. Example, if this one is a final state and this one is a final state, and take A, B, C and D, so you need to combine B and D at one state. Okay, so this is about this rules. 6 rules are there. We will see one by one. Okay, so I am going to take, this is a state diagram. Or you can say the transition diagram. Okay, transition diagram. Fine. So here this is a I have this state diagram. In this state diagram I have Q is Q1, Q2 and Q3. I have Q1, Q2 and Q3. What is a sigma? I have sigma is A comma B. A and B is here. And what is the initial state? Initial state is Q1. How can we identify the initial state? This arrow. And what is the final state? Final state is also Q1 only, because double circle. Okay, and now we need to convert from construct a regular expression corresponding to the automata given below. Based on this, we need to convert in regular expression. So I will show you one by one. Okay, first, the solution here, the initial state and final state is Q1. Just now I shown you here. Okay, initial and final is a Q1. Next, the equation for the three state Q1, Q2 and Q3 are as follows. Okay, we need to make the equation for Q1, Q2 as well as Q3. Next, first equation for the Q1 is Q1 is equals to Q1A plus Q3A plus epsilon. How did you get this? How did you get this? This is based on that state diagram. Okay, based on that state diagram. Okay, so how we got this equation? We got this equation based on this state diagram. So here in the state diagram, Q1, first I am writing the equation for the Q1. Q1 is equals to Q1 on A is going to QA. So first thing, what is this? How you can write the equation? The basic thing is, whenever you are seeing any state, you need to see how many states are coming to Q1. This A is coming to Q1. So Q1A plus, is anyone is coming from Q2? Q2 on anything is reaching the Q1? No. From Q3 is anyone is reaching? Yes, A is reaching. So Q3A and plus epsilon. Why we have taken the epsilon? Because as I told you, Q1 is the initial state and epsilon is added in this conversion. Okay, because of that we added here. So the first equation for the Q1 is Q1A plus Q3A plus epsilon. Next one is Q2. How can we write the Q2? Q2 is equals to, you need to see, is any incoming from the Q1? Yes, from Q1 on B is getting Q2. So Q1 is B, concatenation B. Union, then Q2, when the B is on Q2, then answer is getting Q2. So Q2 on B is getting the Q2 only. Is anything coming from Q3? Yes, from the Q3 is coming B. Q3 on B is going to Q2. So we are written the second equation also. Okay, third one. What is the third one? For the Q3 is any incoming lines for Q3? Only one. Q2 on A is going to Q3, only one. Because of that, Q2 on A is going to Q3. So this is the equations. Okay, I hope you understand how to make equations. Once again I will repeat, Q1 is equals to, so first you need to see how many incomings for Q1 is coming from Q3 and is Q1 is itself also is there. Okay, so for that Q1A itself and Q3A is getting Q1 plus epsilon. Epsilon is initial state. Okay, next in the Q2 we need to see how many incoming for Q2. One is incoming from Q1 and another one is Q2 itself and from the Q3. So Q1, Q2, Q3, and what are the inputs for taking that is B, B and B. Here B, B and B. In the same way, Q3 is equals to how many incoming for Q3? Only one. From Q2, Q2 on A is going to Q3. So, that is third equation. Next. So, here now we will solve these three equations. Next. So, I am taking, before taking this equation, I am taking Q2. Why I am taking means I am analyzing, first I will do the Q2 because we need to substitute the value when we go to the Q1, then I needed the equation. So, based on that you need to select any one of the equation. So, I am selecting the Q2. Okay. From the Q2 same equation is written. Next, in the next I am substituting Q3. I am substituting this Q3. What is the value of Q3? Q2A. So, let us say this is same Q1B, Q2B is same. Now, in place of Q3 I am writing Q2 of Q2A, Q2A. This is substituted, and whatever the B value is here, that is as it is. Okay. Next. Next is, in the next step I am taking the common, like this is same in Q2B plus Q2AB, means this all Q2. So, here I am taking out the Q2 from here. So, what the value we will get? Q2 is here. So, the remaining is B, then here AB, concatenate AB. Okay. After taking the Q2 we got the here this equation. Now, we need to apply the Andrews theorem. What is Andrews theorem? So, this is the thing, R is equals to Q plus RP. This is a, whenever we have this kind of equation, in place of that we need to write R is equals to QP star. So, here how it is getting? So, I will do one thing, here I will write Q2 because Q2 is equals to, Q2 is representing R, okay, and Q1 is representing, sorry, here we need to apply the equation. So, Q1B is representing Q and this Q2 is representing R, okay, and B plus AB is representing as P, this is R and this is Q. So, I will write here Q2 is equals to Q1B plus Q2 B plus AB. So, whenever we have like this, so what it is telling the Andrews theorem? Andrews theorem is telling you need to write, if the equation like C, this is R is equals to, this is Q, okay, plus, and this is R and this is P. So, whenever we will get in this format, you need to write in this equation. So, the same thing we have written here, in place of this R is equals to Q2 is equals to Q, what is the Q here? Q1B, as it is we have written here. Next, here Q P star. So, what is the P here? B plus AB, B plus AB whole star means closure. So, this is in the form of Q is equals to RP. I hope you understand this. Next one is Q1 is equals to, because this is we finished, okay, Q2 is okay. Now, I am taking another equation, that is Q1, okay, second equation. In this Q1A plus Q3A, plus epsilon as it is we have taken from here. Next one is Q1A plus, I am substituting Q3, So what is the Q3 value here? In place of Q3, I am writing Q2A. You can write in the bracket, okay, or directly you can add here, okay. Next, plus epsilon. Next one, here Q1A plus Q2 AA plus epsilon. Now after substituting the Q3, again I am substituting the Q2 because I have the value of Q2 here, okay. Q2 value I have here, so directly this value we need to write here. See, Q1A is as it is. In place of Q2A, means in Q2 we are writing Q1B, okay, and B plus AB whole star. After that, these two A's are here. Clear everyone? I hope you clear. Once again I will repeat you here. The Q2 value already we got with this second equation. What is the answer? Q1B, B plus AB is B plus AB closure, okay. This only in place of Q2. So after that, double A as it is I am writing here, plus epsilon. So this is we submitted the value. Next is we are taking out like common thing, Q1A plus Q1B of B plus AB closure AA. So what is the common in these two? Common is Q1 is a common. So A is here plus this B into concatenation B plus AB, here this should become here, okay, and AA as it is plus epsilon. So here what is this? This is the equation we got. From this again we need to apply the Andrews theorem, okay. How to apply that? Like see, Q1 A plus B, A plus B bracket open B plus AB whole square, whole star AA plus epsilon. So here Q1. So here what is this? Is this in the form of this? Let's check it out. Red color, Q1 means R, okay, and Q1 means this is also R, and this whole thing consider as P, and this is whole thing consider as P, and plus Q. Is it right? Yes. R is equals to Q plus RP. In this format, we have this in this format. So how we need to write? R is equals to epsilon. What is Q? Epsilon is Q. So epsilon plus A plus we need to write RP. What is R? R is, so here we need to write, if it is this equation in this format, so we need to write R is equals to QP closure. So R is equals to Q. What is Q? Q is epsilon, and P means this all is P, A plus B, B plus AB whole square, AA star. So this is all is P. So we have written in this format, and here also we apply the Andrews theorem. Okay, I hope you understand this. Once again I will repeat, this equation is Q1 is equals to Q1 A plus B, B plus AB whole square, AA, okay, AA here bracket plus epsilon. So here Q1 is R as per the Andrews theorem, and Q1 is R, and this whole we can consider as P plus sigma is Q. So this equation we can write R is equals to Q plus RP. Okay, so this is Andrews theorem. So whenever we have this kind of equation, we need to write R is equals to QP star. So R means what is our R here? Q1. So Q1 is here is equals to epsilon. What is epsilon? Q, this Q, and P closure. P closure means whatever you have P, then again you need to give the closure to it. Okay, so this is equation. Next, is there any possible to do? Is there any possible to do? Yes, we need to remove the epsilon, A plus B, B plus AB closure, AA closure. So this is your, hence the regular expression is A plus B, B plus AB closure, AA closure. So this is your final answer. Final answer. Okay, so this is, we converted from finite automata to regular expression. Okay, once again I will quickly tell you about this. Here the initial state and final state is Q1, initial state and final state is Q1. The equation for the three state Q1, Q2, Q3, these three states, and we need to write the equation. Q1 is equals to, very easy way you can make the equation. Just you need to check whatever the incoming to the same state, like I am checking for the Q1, so you need to check it how many incomings are there for the Q1. One is epsilon means initial state, another one is A by itself Q1, and another one is Q3 on A. So Q1 on A and plus Q3 on A is getting Q1 plus epsilon. Okay, this is already we told in initially we will take the epsilon in finite automata to regular expression in conversion. Q2, what is Q2? Simple way, you need to check the Q2, how many incomings are there from Q1 and Q3 as well as by itself Q2. So 3 incomings are there, on which input we need to write. Q1 on which input is getting the Q2? On B. When Q1 on B, we are getting Q2. Q2 on B is getting Q2 only, and Q3 on B we are getting Q2. So because of that, on what output we are getting the Q2. Next, Q3. In the Q3, only one input is coming from Q2 to Q3 on A. So Q2 A. So here I am taking the Q2 equation. Okay, Q2 is equals to Q1 B plus Q2 B plus Q3 B, same equation, and here we are substituting the Q3. Q3 is Q2 A, whatever the value here, Q2 A we are substituting. After that, Q1 B plus Q2 of B plus AB. here we have taken the common one is q2. So, after that b plus ab. Next one is q1b b plus ab whole square, sorry, whole closure. So, how we are getting? With the help of Andrews theorem. So, this is here q2, this one q2 is r, q1b is q, q2 is r, b plus ab. So, whatever the equation we have, that is equivalent to Andrews theorem. So, at that time you need to write r is equals to qp. So, r is, what is r here? q2. r is equals to qp. What is q here? What is q here? q1b, q1b, b plus ab whole closure for p closure. In that equation we finish this. Why we are not telling this is a final regular expression? Because here q1b is also there, we did not substitute here. So, because of that q1, again we are taking the next equation q1, q1 is equals to q1a plus q3a plus epsilon. So, here q1a plus, just we are substituting the q3 q2a, and whatever the a is, that is as it is. Here q2a is here, then whatever the a from here is as it is. After that, in the next equation we are substituting the q2. In place of q2, we no need to substitute this because already we solved that. So, whatever the result we have, we need to take that q1b of b plus ab whole closure, q1b b plus ab whole closure, not here, that should be here, whole closure, and this double a is as it is plus epsilon. So, next is here, which one is a common? Common is the q1. So, we have taken the common q1, a plus b whole b, sorry, a plus b bracket b plus ab whole closure aa. This is a equation after taking the common of q1. Next, this epsilon, and this is this equation, again we need to check, this is come under in Andrews theorem. q1, okay, this is q1, q1 is equals to this q1 a plus b, b plus ab whole closure aa plus epsilon. So, r, this whole will consider as p plus this q. So, we can write that r is equals to q plus rp. If the equation is in this format, so we need to give the answer r is equals to qp star. So, here q is a epsilon and p closure, this whole is a p and the closure. After that, we need to remove the epsilon, a plus b, b plus ab whole closure, aa whole closure, then this is your final answer. Hence, the regular expression is a plus b, b plus ab whole closure, aa whole closure. So, this is your final answer. I hope you understand. Okay. If you did not understand, no problem, you can message me or contact me, or you can see again this video, then you can easily understand this. Okay. So, today I am going to stop here, but before that I am going to give you the homework. This is very simple, this is very easy. This is homework. I am going to submit the Google form, okay, in the description. For this, you need to solve and submit through the Google form. And in the last class, I gave you the homework like assignment. In the assignment, many of them submitted the form. Around 62 students submitted, including section A and section B. The remaining as pending. Today also I am opening, and today in the group I am going to send you the correct answer of that construction of epsilon NFA to not regular NFA. Okay, fine. Thank you. We'll see you in the next class.